Today we're going to talk about the special ability of the Jetstream tidal lagoon. Due to its elliptical shape, it enables the incoming tide to move around the outside of its curved wall in a manner which speeds up the tidal flow. This action creates a new form of kinetic energy that was never there in the sea before. And we are able to harness this kinetic energy by means of having special pumps attached to the outside of the walls of the lagoon. And this means then we are able to activate these pumps into the divided lagoon system into the rear section, and by having hundreds of these pumps pumping in as the tide comes in, we are able to create inside a much higher tidal head height than there is outside, so the tide flows out and on upstream in a normal manner through the second turbine house. Now this means we have an ability to create our own internal head height, which means we can effectively pump enough water in, or we can even pump water back in from the outflow of the turbine house, so that we are technically recycling some of the water back into the lagoon. And this means we can go through the slack water period of the tide, ready for the next incoming cycle. And this means we can have a system where we are creating 24-hour power. The second key feature that we see on the monitor is that the lagoon has floating solar array within it. And this means that this lagoon can have huge amounts of solar panels within the structure, and those panels then give it an ability to create electrical energy and have it transferred by cable to shore during the daytime. And then at night time we can take advantage of the low off-peak electricity from the tidal effect, and these combined power sources are all carried ashore in a cable system where we can split huge amounts of fresh water or even seawater, so that we get the gases oxygen and hydrogen. Now, the hydrogen gas can power gas-fired power stations. It can fuel cell cars. It can even have a fuel cell power station, small scale, run by this gas itself. So what we've got is a complex and not just a tidal system within the structure and dynamics of this system. So we have an ability to produce power as tidal. We can hold and store water in a different way, so we are actually holding energy in stored water. And then thirdly, we have the dual complex of daytime solar and cheap off-peak tidal, where we can afford to split fresh water or seawater to get oxygen and hydrogen on a very large scale. The great advantage of our lagoon wall structure, apart from being curved, these wall units are made from hollow box structures, so when they are being built, we take up all the silt within the sea area of the lagoon, and that is pumped within the box structures in the walls. To compensate for this light silty material, we take material from the Cornish China clay industry, the waste material, which is granite based, and this is a heavy dense material, and we top up these boxes with that material. So all the material within the wall is waste, and over time and with water pressure, those two materials turn into a form of concrete or cementation process, and this means that huge amounts of waste material are actually in the wall structures. And so we can afford to spend more money and use high-tech materials in making the box structures which form the wall. And the overall picture is, the faster we want to build in the future, the more ports we employ making the box structures. So if we have 3 ports building the box structures, then a lagoon may take X number of years to complete. But if we bring another port online, we are reducing the time to build by a quarter, which in commercial build time is a huge saving in structure. So we have an ability that everything we build and make can travel in a ship's container. So if we were exporting to Canada in the future to make a tidal lagoon system there, we could have one container ship carrying possibly 5 kilometers of wall structure boxes to their nearest port, ready for setup and build to go in the sea within that country. So we have, as we go along, an export industry. We have people who, from the naval side, who worked on submarines. These people currently split seawater for the oxygen for the submarine crews. So we have these skills in Plymouth and Portsmouth and other ports within the UK, and knowledge of splitting water. So this is a transference of those skills for this new giant hydrogen, oxygen, gas industry. So what we have is a resource in the sea, which is the more we build lagoon walls, the more resource we create. A lagoon wall, our life expectancy is plus 100 years, and that means in comparison, a nuclear power station, we will be lucky to see it last 50 years, and then you have to replace it. Also, you have the problems with the nuclear power station still being radioactive and needing monitoring. With the items like solar itself, solar has a life of 25 years, and so those units have to be replaced, as will ours. But we are already planning in our design to have special coating systems for our defunct solar panels so that they can become kit building structures for low-cost homes in third world countries in the future. We also have a situation where the offshore wind has a life expectancy of 25 to 30 years,